Okay, we're moving on to our last lesson on scatter plots. Your target, you can analyze scatter plots and lines of best fits. That's the two things you're going to be able to do, or three. So vocab aligned with this. You need to know what a scatter plot is. It's a collection of data points not connected. So a collection, just a collection of points. You don't connect them. It's not like tic-tac-toe. You just plot them. And if two things have a correlation, it looks like they can form a line. So here's the different types of correlations you can have. You can have positive correlation. It looks like the line is increasing. You can have negative correlation. Looks like it's decreasing. Or they could not be related at all, and you would say no correlation. Can you see the difference? Looks like a line. Looks like a line. It's all over the place. Can you visualize that? Line, line. There's no way you can draw a line when they smush together. All right, let's go ahead and create a scatter plot. Now, this is where you're probably not going to love it very much. You're going to have to be careful about scaling, and you're going to have to be, well, that's pretty much it. And also you're going to have to realize you're going to estimate points. These are estimated values. You don't need to get your ruler out and be exact. Okay, so dollars spent and the gallons you bought. Dollars and gallons. So what do you think is dependent on what? Does my money depend on the gallons, or does my gallons depend on the money? Money depends on the gallons. So then money is the Y, gallons is the X. All right, so let's see. I analyze how far out I should go. Looks like my highest value, whoops, is 2.8. My lowest, oh, just kidding, it's 3.3. My lowest is 1.1. So I think I can maybe go by 0.5. 0.51, 0.52, 0.53, 0.5. That's what I'm going to do. So this is 0.51, 1.52, 2.53, 3.54. So all of these little ticks are 0.5, 0.51, because I want to spread it out a little bit to make my life easier. So if you don't like, if this is confusing you, you can move that. And now you should be able to see then that I went 0, 0.51, 1.52, 2.53, 3.54. Now I gotta look to see what my values for Y needs to be. What's my highest value? 13. And my lowest is 4. I'm thinking 2's. Okay? So 2, 4, 6, 8, 10, 12, 14. I'm just going to go up to 16. Reminding myself this is the dollars and this is the gallons. And now you plot. And boy, is it fun. You just estimate. I am not going to be a perfectionist here. So I have the point 2.5 and 10. So X is 2.5, Y is 10. Hey, that wasn't bad. That one was easy to do. Now 2.8 and 11. So 2.8 is a little bigger than 2.5. Hunter, be doing this. And then up to 11, halfway between. Making an estimate. 2.3 and 9. So a little less than 2.5, right? Do you agree with that? Yes or no?
Yeah.
Okay. And then I need to go to 9, so right under 10. See, it looks like one big oblong shape there. 2.6 and 10, a little bigger than 2.5, and at the 10. 3.3 and 13, thank goodness I can get away from that little range of cluster. So 3.3 and 13, it's about right there. 1.3 and 5. Oh, right there, approximately. 2.2 and 8, a little bigger than 2, up to the 8. 1.1 and 4, a little bigger than 1, to the 4. Does this look like it has a correlation?
Yes.
Does it look like a line is forming?
Yes.
I can see a line. Like to me, it seems like they're congested in one area. Looks to me like a positive correlation on that. So that's learning target number 1. You can create a scatter plot. Can you, given a collection of points, plot them? Can you think about scaling? How are you going to scale? Notice how I thought about it as what's my smallest, what's my biggest, and then I went from there. Ew. Okay, I want you to do this one. Okay, so again, I go x first and then my y. So 0 and 59, so that's right under 60. So that's about right there. 500 feet and 59.2 temp, so 59.2 is right around there too. 1,061.3, so it's a little bigger than 60. 1,555 and a half, so about there-ish. 2,000 and a little bigger than 40. 2,500 and almost 30. 3,000 and almost 30. 3,500 and almost 20. 4,000 and kind of close to 30. 45,000 or 4,512. 5,000.6. So notice I definitely am not trying to get the perfect point. I'm making a rough estimate. You should be able to visualize it does kind of look like a line, and you would be able to make a line of best fit. Okay, you always can. Okay, next. Whoopsies. I want you to tell me, no, this isn't in your notes. I just want you to tell me if it's positive correlation, negative, or none. What's this one?
None.
Okay. What's this one?
None.
This one?
Positive.
You can see the line. Good. Aye. What's that one? This one?
Negative. Negative.
Can you see? That's a difficult one. Can you see that it is kind of like that negative line? That one?
Positive.
That's more like exponential growth almost, but yep.
Negative.
Ooh,
None.
you're good. Ooh, good job. Ooh, yay.
0.
Okay. So move to your line of best fit page. We've talked about this. A line of best fit goes through the middle of a collection point. It goes through as many as you can possibly go through. Notice a line of best fit here. You try to find that middle ground. I try to find the middle point between. Our lines of best fit might be slightly off because what I view as the middle and my making things like straight is going to be different than yours. But it's around the area. Do you know how to analyze it as your target today? So from this graph, I want you to make a line of best fit. Go through the middle of the points. Try to find that middle ground on this one. So everybody go through it. Looks like a negative correlation, right? So would my slope be positive or negative to this line?
Negative.
And that's where I'm going to have you analyze your knowledge of slope and lines of best fit. Because they're going to ask you a question like, what's the equation of this line of the line of best fit? Try to match slope is what I would do. Play match slope game. Okay. Now we're going to make predictions using line of best fit. So which one do you think is independent and dependent? Do you think my height depends on my age or my age depends on my height? Height to age. So height is dependent on how old I am. Up to a certain point, right? I mean, once you get to be about your age, it doesn't work that way anymore. Okay, let's analyze this. What should I go up to? My smallest is 9 for x, and my biggest is 21.
Go up by
Five.
10s.
5,
Yeah,
10,
five,
15.
five.
Oh, that's little.
5.
2, 4, 6, 8, 10, 12, 14, 16, 18, 20.
Yeah.
Let's do that. I mean, we're going to be off the graph a little bit, but that's okay. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Maybe this one's going to be 10s, right? Because 50 to 70-ish. 10, 20, 30, 40, 50, 60, 70, 80. And plot. So everyone's plotting here. 9 and 54. 13 and 62. 15 and 64. 17 and 68. 18 and 68 and a half. Okay. 21 and 68 and a half. So don't be copying mine. You do your own guess. I'm just talking through. All right, so I'm going to go ahead and try to make my line of best fit. You want to try to go through the middle point. So I kind of want to go right there, actually. That looks good. We're all going to be slightly different. That's okay. Can you analyze it? Now here's what I mean by analyze it. I use this line to help me make guesses. So, based on this line, how tall can I expect to be at 25? Well, what do you think is going to happen here? It's kind of stagnate, right? And I made it look like it was more, so 25 would be over here. I would say approximately 70, based on my line of best fit, not my logic, my line of best fit. I would expect that at 25, my height be 70 inches. How old, based on your line of best fit, how old is a person that's 65? So I go to the 65, I go over, here's my 65. How old are they? How old does it show? Okay, you're not following me. I go to my 65, I go to my line of best fit, I go down. They are about 18 years old.